All right, everyone, next lesson, 10.3, the counting principle and permutations. Okay, so these are two separate concepts here. Counting principle is the first concept, and then the concept of what are called permutations is the second concept. The counting principle is a way of figuring out how many total outcomes there are when you're making multiple selections of a thing. So suppose you have an example where, like, you're looking at a menu, like this example right here. You're allowed to choose one soup from the soup category and one sandwich from the sandwich category. How many different ways, how many different outcomes could you select, basically? How many different combinations of soups and sandwiches are there? Well, if there's 2 soups and 3 sandwiches listed here. There's chicken and tomato soup, 2 of them, and then there's turkey, tuna, and cheese sandwiches, 3 of them. Then the counting principle is very simple. All you do is you multiply the options. 2 times 3. Or 2 times 3 equals 6 total different outcomes. That's the counting principle. You just multiply the total number of outcomes for each category, and that's the total number of overall outcomes. And then you could also make what's called a tree diagram to look at this visually, just to see why the counting principle works, why it's just multiplying the outcomes. So like if you had chicken, if you pick chicken as your soup, well, with chicken, you could have turkey, you could have chicken and tuna, you could have chicken and cheese, right? That's 3. That's 3 different combinations right there. And then you could do the same exact things with tomato. You could have tomato and turkey, tomato and tuna, and tomato and cheese. That's not really a tree. I didn't draw it as a tree diagram, but we'll do that in the next example. You roll a number cube and also flip a coin. How many different outcomes are there? Well, on the cube, aka a number cube is just a dice. You have 6 outcomes, right, that are possible. On the coin, you have 2 outcomes, heads or tails. Multiply them. There are 12 total outcomes possible. So the tree diagram would look something like this. Let's see. You would do a 1 in a heads. So like a 1 in a heads, a 2 in a heads, a 3 in a heads, a 4 in a heads, 5 in a heads, or a 6 in a heads, right? And then you could also have a 1 in the tails, a 2 in the tails, a 3 in the tails, a 4 in the tails, a 5 in the tails, and a 6 in the tails. Those are all the possible different outcomes you could get when you roll a number cube and flip a coin. You just basically draw out all the combinations with these little branches here, and that's basically why it's called a tree diagram. But if you have larger examples like this, 7 t-shirts, 3 sweatpants, and 5 pairs of sneakers, you're not going to do a tree diagram for that. It would take too much space to draw it out. You would just use the counting principle. 7 times 3 times 5, which is 105 outfits. All right, that's it for counting principle. All it is you just multiply the different outcomes for each category, and then that gives you the total number of possible overall outcomes.